Number 1 says a group of students were asked how many pets they each have. The results of the survey were recorded as follows. So we have a bunch of random numbers here. So let's say we went out, we asked some people, hey, how many pets do you have? And this is the answers that we got from people. The numbers aren't organized, right? So they're all just kind of randomly thrown out here. So it's kind of hard to tell, if you wanted to ask the question of, okay, well, how many pets do most people have, or at least, within this survey? It'd be kind of hard to tell because the numbers aren't organized. So what we want to do is that we want to organize the numbers in a way that it's kind of easy to read, or easier to read. And we're going to do that by making a dot plot. Pretty simple. As the name suggests, we're going to do a dot for each time that we see a particular number. Looks like the smallest number is 0. So on my number line, I'm going to start with 0. And it looks like the largest number, so 0, 1, 2, 3, looks like 7 seems to be the largest number. So we'll just count from 0 up to 7. And again, what these numbers represent is that these are the number of pets that people said that they had. So what we're going to do, as the name suggests, we're going to put a dot for each time that we see a number. So for instance, there's 0, so I'm going to put a dot, one dot, for 0, and then I'm going to cross it off. I want to make sure that I don't forget any numbers or I count something twice. So the way that we make sure that we get an accurate number is we'll mark it off each time we go. So here's a 3, so I'll put a point for a 3. There's another 0, so that'll be 2 now at this point. 2 and 1. And what you can do is that you can you don't have to count one at a time. Sometimes what people do is they'll kind of do groups. So maybe you say, oh, okay, well, there's 2 2s, so I'll put the 2 2s. Or if you want, maybe count in groups of 3s. 1 1 0, 1 1 0. I wouldn't try to count too much ahead, though, because then you lose track of where you are, and so we don't want to make any mistakes. 7 3 4, so I'm just going to count in groups of 3. That's an easy number to manage. 7 3 4. 2 1 2, 2 1 2, 1 2 2, so I've got 1 2 2, and then to finish it off we've got 3. Now we want to make sure that we counted correctly. Let's go back and make sure, how many people did we even talk to here? Right, because we got answers from how many people? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So it looks like we talked to a total of 20 people. And then so for our dots, we should have a total of 20 dots. So there's 3. 5 more would be 8. What do we got here? 1 2 3 4 5 6 7. So 8 plus 7 would be 15. 3 more would be 18. 1 more would be 19, and then 1 more would be 20. So it looks like it all matches up. So what the dot plot does is that it allows me to real quickly, without taking a whole lot of time by looking at a bunch of random numbers, if I said how many people had 5 pets, well, no one said that they had 5 pets because there's no dot there. Or if I said how many people said they had 1 pet, well, I could look real quickly and see, oh, 5 people said that they had 1 pet. So it's a lot more organized and more neat for me to be able to kind of see things other than these random numbers here. All right, so that's the picture part of it. Now we want to kind of do the math part as far as kind of crunching some numbers. We want to figure out one thing. We want to figure out what this x bar represents, right? And then we call this x bar, well, because, as you might guess, it's an x with a bar over it. That's just our symbol for the mean, which is oftentimes more informally referred to as the average, right? So the mean is the average. And so instead of having to write out the word mean or average, we just use that symbol for it. To find the average, you just add everything up and divide by the number that's there, which in this case would be 20. We could do that, but we have a calculator here that also kind of does the work for us. So what we're going to do is we're going to load these numbers into the calculator and have the calculator do the work. So let's go ahead and get the calculator on and open if you don't already have that there. And then from this kind of home screen, what we're going to do is that we're doing statistics. So we're going to hit the stat button. And then what we want to do is we want to load the numbers into the calculator. So we want to edit, meaning we want to put numbers into the calculator. So I'll just select enter. Now your calculator may or may not already have numbers in there. If it does, that's all right. Just scroll to the top and hit clear. Don't hit delete because that'll take out the entire thing. So we just want to clear it. So hit clear. and then when you scroll back down, the number should be gone. Let's say, for instance, there's some numbers over here in L2. Let me just throw some numbers in here real quick. If there's numbers over there, you just do the same thing, which would be to hit clear, scroll back down, and then there we are. So we want to start this problem without any numbers in L1 or L2. Now, to type in the numbers, there's two ways we could do this. You could go with the original list, 0, 3, 0, 2, 1. Or I could look at it this way and say, oh, there's 3 zeros. So I'll type in 3 zeros. 1, enter, 2, enter, 3. Right, 3 zeros. And then there's 5 ones. So I'd hit 1 in 5 times. Not hitting 5 in, but hitting 1, because that's the number we're talking about, and then the number of times. Does the order matter? No, the order doesn't matter. So you want to type them in like this, that's fine. You want to type them in like that, that's fine too. So the calculator figures it out either way. For me, I don't know, I kind of like that it's already organized. So what do we say here? 3, 4, 5, 6, 7. So I like just going off our dot plot since we got it organized. So let's go ahead and put that in there. And we've got 3 3s. 2 and 3, and then we've got 1 4, and then we've got 1 7. And remember, a second ago we said that we should have a total of 20 responses to our survey. If I look at my L1, it says L1 20. That means that it was keeping track of how many numbers I put in so far. So that means that I've put in 20. If yours says, hey, mine says 21, well, 21 represents the next spot after it. There shouldn't be a number in there for 21. So we should have just 20 numbers. So the numbers are in there. Now we just need the calculator to do the work. So we're going to go back to stat. And this time, now that the numbers are in there, we're going to scroll over one to calc for calculate. We want the calculator to do some work now. And just the first entry there, one variable statistics. One variable because we've only asked one question here. How many pets do you have? We didn't say what color is your hair and how many pets do you have, right? We didn't ask 2 questions, we only asked 1 question here, so that's why we're just doing one variable stats. So hit enter, and you get here and you're like, hey, it didn't do anything. Well, you just got to hit enter one more time, and then it'll bring up some numbers for you. So the first number that we're looking for, the X bar, that's our average, so it says 1.95, so let's go ahead and fill that in. So our average is 1.95. And that should make sense because if we look at our graph, you know, what was the most common, what we refer to as the mode, what happened the most was 2. So, you know, an average of 1.95, yeah, that makes sense. An average of 10, that wouldn't make sense because there's not even any numbers out there, so that doesn't make any sense. The other number here that we're interested in is what we refer to as the standard deviation. So that's where it says this S. So S is equal to, let's say, 1.60. And what the standard deviation measures is it measures how spread out are the numbers. Are most of the numbers close to the average, or are they spread out from the average? So if we ask this question, how far away are most of these numbers from 1.95, I think we'd say that most of them are, most of the numbers are within 1 or 2 of the average. You got a couple that are out here, and we'll talk about that in a minute, but most of them fall within that range. So what we end up doing here is that the standard deviation, how we kind of mark this off, we refer to this as the normal distribution curve. What it does is it shows where most people fall or fit into a given situation. So in this case, we're talking about how many pets. So you see the widest part here represents where most people are. Now, in this case, are there people that have more than the average or less than the average? Sure, but most of them fit around the average. So the way that we would set this up, or the way we would label this, is that I'm just going to draw a little curve here that matches with the one that's up there. And the average, we say that the mean is a measure of central tendency. It's a measure of kind of this idea of the center of the data. So what I would have for average would be 1.95. And then what the standard deviation does is it tells me how spread out the numbers are. So what this would mean is that I would say that when it says 1.60, what I would do is that I'm going to add 1.60. So I'm going to say plus 1.60, and then I'm going to say minus 1.60. And what this is allowing me to do is that it's setting a range of, well, most of the people said in between this and this. And so we were trying to figure out what this and this would be in this case. So what I could do is I could just clear that out. So let's do 1.95 plus 1.60, or just 1.6. And so I get 3.55. 3.55. And I do the same thing, but now this time I subtract, because I'm trying to figure out what it would look like on the left side. So 1.6, and I get 0.35. So what this is telling me is that it's telling me that most people, not all, right, because there's still this piece over here, and then there's still this piece over here. So did everyone have in between 0.35 and 3.55 pets? Well, no, because there were some people that had 0 pets. This person had 4. This person had 7. So it doesn't cover everyone. It just covers most. Obviously, you can't have a 0.35 of a pet. You can't have a 3.55 pet. So what we're going to do, to answer this question, most students have between, what we'll say is that we're going to round 0.35 down to 0. So we'll say 0.35 rounded down. And then 3.55, we're going to round that to the nearest whole number. So we'll round that up to 4. So we'll say 3.55 rounded up to 4. Right? So we just rounded down and rounded up. So most students have between 0 and 4 pets. Is that true? Yeah, almost everyone has in between 0 and 4 pets, at least according to this survey. We only have one person out here that said that that doesn't fit into that range. And so that gets into the last part of the question, which is then asking, okay, well, which number is an outlier and why? So what an outlier is a number that lies outside of the range of most of the data points. So the outlier, you notice that this is kind of far away from the rest of the group. So we would say that that would be an outlier. So what we would say is that 7 is an outlier because it is far away from the rest of the data points. So again, an outlier just represents something that it doesn't fit with the group, right? So if we talked about an outlier of height, if we were all in a room and then Kobe Bryant walks in, he would be an outlier, right? Because there's not that many people that are, 6'4", 6'5", whatever it might be. So the idea of an outlier is that it fits with outside the group. So most people said, yeah, I've got 1 or 2 pets, and then you got this person saying I got 7, right? So that fits outside of what most everyone said. And we have a test to determine if something is an outlier, and we'll kind of look at that in another problem. For this problem here, though, I think the idea is just to get you to see that an outlier represents something that doesn't fit with the group. All right, so let's go ahead and stop the video here, and let's try number 1 on the right side.